Hello, everyone. Happy Wednesday. Welcome to the Chem Help ASAP live stream. So, I'm guessing that many of you are either starting your chemistry classes for the fall or you're getting ready to start your chemistry classes for the fall. And one of the things, especially if you're taking a college level class, is knowing significant figures and knowing how to work with scientific notation. Now, if you're in high school, these will probably be explained to you at least a little bit. But if you're in college, a lot of these things are already assumed that you know how to deal with. So I want to take the time in this live stream and really go over in detail what significant figures are, how you count them, all of the rules that go with them. And then we want to talk about scientific notation and how we use scientific notation and even converting standard notation into scientific notation and back out again. And then we're going to do some problems using both our sig fig rules and throwing in a little bit of scientific notation, because there are sets of rules when you're doing addition, subtraction versus multiplication, division versus all of your mixed operations, and dealing with scientific notation and sig figs, so that when you're doing your calculations as you work chemistry problems, you can report the answers to the correct number of sig figs, and so scientific notation won't trip you up because you will be using it quite often. And there is one thing in particular that I want to show you about your calculators, where if you don't get the notation correct in your calculator, basically you have to speak calculator ease to your calculator, it will give you the wrong answer, which is so frustrating when on paper you're trying to do the math right and your calculator gives you the wrong answer. So that is going to also be part of this live stream. So we're going to go over a lot of rules, a lot of examples, and we're going to do a lot of math problems. Okay, with that being said, let's go ahead and get started. Okay, so first, let's learn to let's learn to identify our significant figures. So let me get my pen up here. If you have a non-zero integer, then that is automatically going to be significant. So I've got a couple examples here. So let's take our first one, 2,351. A common question is how many sig figs in this number? Because these are all non-zero integers, there are 1, 2, 3, 4. So there are 4 what we call sig figs, because apparently saying significant figures just takes too long. So sig figs is usually what we talk about. Okay, so for our second number here, again, any non-zero integer is going to be significant. So there are 2 sig figs. One thing to note with this example, so it does have a 0 right here. That is so that you can see the decimal more clearly. So anytime you're writing an answer down and you want to start with a decimal, make sure you put a 0 to the left, because it helps highlight that there is a decimal point there. So what you don't want to have happen is you've turned something in and you've put a decimal point down, but maybe it doesn't show up very well, and you get points off for that. So always put a 0 in front of a decimal point, again, so it's really clear that there is a decimal point there. Okay, for our last example, we have 1, 2, 3, 4, 5, 6 sig figs. Again, the non-zero integers are really easy. They're automatically significant. Okay, but now let's talk about our zeros, because we have multiple rules depending on what kind of zeros we are talking about. Some are significant, some are not significant. Okay, so rule number 1, we're going to talk about what are called captive zeros. These are zeros that are in between significant figures, or in between non-zero integers. So if you look at my first example, 301, this 0 is captive. It's in between a 3 and a 1, so it is in between 2 significant figures. That means it is significant. So captive zeros are maybe we'll say are sig figs. These are sig figs. All right, so how many sig figs in 301? there are 3 sig figs. Again, because that 0 is significant. So let's work our other example with captive zeros. So you can see in my second example, 40,079, I have 2 zeros again that are in between significant figures. Those are both captive 0 and they are both significant. So it doesn't matter how many zeros are captive. You could just have 1, you can have 2, you can have 10. As long as they are in between 2 significant digits, then those captive zeros are significant. So for this number, we're going to have 1, 2, 3, 4, 5 sig figs. Okay, let's look at our last example. We have 2 sets of captive zeros. This first one here is in between the 5 and the 3, so it is captive, it is significant. And this second set, it's a double set, is in between the 3 and the 7, so they are also significant. So it's not that you can just have one set of captive zeros that are significant. As long as the zeros are captive zeros, it doesn't matter how many sets are in the number, they are significant. Okay, so for my last example, I have 1, 2, 3, 4, 5, 6, 7 sig figs. I'm kind of partial to the captive zeros personally. I don't know why. I just really like them. They're very easy and I think they're kind of cool. So anytime you have a captive 0, it is going to be a sig fig. Okay. Now let's look at rule number 2. We're going to look at what are called leading zeros. These are zeros before your first non-zero digit. So looking at our example right here, you can see I have 2 leading zeros. They are zeros that are to the left of my first non-zero integer. Leading zeros are not significant. So these are not sig figs. So when I'm counting up sig figs for my first example here, my 0.07391, those zeros are not significant. I only have 1, 2, 3, 4 sig figs. Okay, on to my second example. So again, I have quite a few leading zeros, but they are not significant because they are leading. They are to the left of my first non-zero digit. However, I've got another 0 right here. Is that significant? Yes, because that is a captive 0. So for counting up my sig figs for this example, I have 1, 2, 3, 4, 5 sig figs. So often you find in numbers you'll have multiple types of zeros. So this is why you need to be able to identify what kind of 0 it is, and then is that kind of 0 significant or not. Okay, let's take our last example. We have a lot of leading zeros. How many is it? 1, 2, 3, 4, 5, 6, 7, 8 after the decimal point, and then 1 before. They're all leading zeros. They are not significant. So how many sig figs in this number? 1. There's only 1 sig fig. Which when you're first learning about sig figs can feel a little bit weird and feel a little bit wrong, but trust me, if all the zeros are leading, like in that case, that number has 1 sig fig. Okay, our third type of 0 is called a trailing 0. Now, these are zeros that come to the right of any non-zero number. They come afterwards. Okay, trailing zeros are sometimes significant and sometimes not significant. So the rule for trailing zeros is they have to be to the right of the decimal and to the right of a significant digit to be significant. Okay, so they must be to the right of the decimal and so you have to fulfill both of these conditions and to the right of a significant figure. Okay, and this can feel a little bit weird until you see an example. So take this example right here, 1,000. Whoops, I didn't mean to make that mark. These are trailing zeros. They're coming after our significant digit, so they have fulfilled one of the conditions, but they are not to the right of the decimal. So these trailing zeros are not significant. Only this one is significant. So 1,000 written like this has one sig fig. Okay, let's look at our next number here. We've got two different kinds of zeros. So we've got our captive zero here. We already know that's significant. That's great. We love our captive zeros. And then we have our trailing zeros here. Now they are definitely to the right of a significant figure, but they are not to the right of the decimal. Therefore, they are not significant. Remember, we have to fulfill both of those conditions. So this number has 1, 2, 3 sig figs. Okay, next, we've got a lot of different zeros here. So we have some leading zeros and some trailing zeros. Well, we already know that our leading zeros are not going to be significant. So then the question is, are the trailing zeros significant? Okay, they are to the right of the decimal, and they are also to the right of a significant figure. So yes, they are significant. So these two trailing zeros have fulfilled the two conditions for them to be significant. Therefore, I have 1, 2, 3, 4 sig figs. Okay, let's take a look at this monster down here. We've got a lot of zeros here, so let's identify what kind we have. So these ones on the left, these are leading zeros. We know they're not significant. These zeros in the middle here, these are captive. They're in between a 2 and an 8, so they automatically are significant. We have some trailing zeros. Okay, so are they to the right of the decimal? Yes. Are they to the right of a significant figure? Yes. So they are significant. So we've got a lot of sig figs here. Let's see. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 sig figs in this last one. Or sorry, this really long one. This is not my last one. Okay, so this is my last one here, and I wanted to show this because this is a little bit of a trick you can use. So you remember when we did 1,000 up here? Let's see, where is my pointer? Here it is. Erase that. When we talked about 1,000, that only has one sig fig. Well, what if you wanted to make those zeros significant? Well, you could do scientific notation, but we haven't talked about that. But one kind of quick and dirty trick to make those trailing zeros significant is if you put the decimal place afterwards, then what you do is you tell the reader, hey, those are zeros, they are trailing, they're not supposed to be significant, but actually in this case they are. So for this 100 with the decimal point right there, that gives 3 sig figs for that 100. If it did not have the decimal, it would only have 1 sig fig. So this is really helpful for writing numbers like 100 or like 20, and you want to make just like 1 or 2 trailing zeros significant. Again, it's kind of a little quick and dirty rule to make that happen. So maybe you weighed out 100 grams exactly, and it was 100, it was 100, and you want to again tell the reader, hey, no, actually those zeros are significant. Again, a quick and dirty way is just to put a decimal there. Okay, all right. Oh, OG Benchmarks has joined us. Good, thank you, OG Benchmarks. Okay, those are our rules for zeros, so make sure you keep those in mind. Captive zeros, which I love, are always significant. Leading zeros, never significant. Trailing zeros, sometimes significant. Again, they must be to the right of the decimal and to the right of a sig fig. Okay. Now let's talk about one more thing about significant figures, and those are exact numbers. So the first time you're going to see this probably is when you're talking about conversion factors. So if a conversion factor is exact, then it's going to have an infinite number of sig figs. So let me write this here. Exact numbers have an infinite number of sig figs. So I have a couple examples. There are exactly 1,000 meters in 1 kilometer. This is the definition of a kilometer. So you can think about that 1,000 meters as being able to be written with as many zeros as you want out here. Now remember, these trailing zeros here are to the right of the decimal and they're to the right of a sig fig, so they are significant. Again, this is a definition, and we use this as a conversion factor. It is exact. It has an infinite number of sig figs. The same is true if you're converting between liters and milliliters. By definition, there are 1,000 milliliters in 1 liter. That has an infinite number of sig figs. So a lot of times when I'm doing problems, I'll just use the infinity sign to say, hey, this number is exact. It has an infinite number of sig figs. Now, these conversions in the metric system are all going to be exact, whether you're converting from meters to kilometers or nanometers to meters or anything like that, terabytes to bytes. Those are all exact conversions. Now, there are a couple of other kind of random exact conversions, and I just want to show you one of them here, and that is 1 inch equals 2.54 centimeters. That's something that you'll probably run across in your class at least a couple of times. That is an exact conversion, and because it is exact, it has an infinite number of sig figs. Okay, the second type of exact number that you're going to come across are counting numbers. So these are numbers that can't be fractions or decimals. So if you're counting people and you counted 10 people, you're not going to count 10 and a half people or 10.1 or 10.2. It's going to be 10 people or it's going to be 11 people. That is an exact number. Again, it's called a counting number. So this works for people or planets or atoms. So if you have 5 atoms of magnesium, that is an exact number. You're never going to have a fraction of a magnesium atom. At that point, you'd have a subatomic particle, but it is not a fraction of a magnesium atom. So if you have a counting number, then those are also going to be exact numbers, which means I didn't put my symbol. These both have an infinite number of sig figs. Okay. Questions about counting sig figs? Once you get practice with it, it'll come a lot easier. But when you're first starting out, even if you can make a list of the rules, especially of the rules of zeros, that can be really helpful. All right, so now let's talk about scientific notation, because we need to be able to work with our zeros to actually do scientific notation correctly. Okay, so scientific notation, there are a couple of rules with scientific notation. So when you write scientific notation, you're always going to have just one digit to the left of the decimal. Only one, ever. All of your numbers are going to be sig figs. So this is the great thing about scientific notation, is it's automatically going to pull out any zeros that are not significant. This is why I love scientific notation, because then I don't have to worry about, oh, is that zero significant? Is it not significant? Once it's in scientific notation, bam, all your zeros are significant. Okay, if you have a positive exponent, this means you have a really big number. So it's going to move the decimal to the right, however many places you need to move to the right. And of course, the reverse is true. If you have a negative exponent, that means you have a very small number, and it does move the decimal to the left. So I just gave 2 examples here. So you can see in this example, we have 1 digit to the left of the decimal. This is a big number. It's got a positive exponent. So it means that if I wanted to move this to standard notation, which is how our numbers were written before, then I would move this decimal 7 places to the right. Our second number here is a very small number. Again, it's got a negative exponent. Again, we just have 1 digit to the left of the decimal. And this means if I were to write this in standard notation, I would go 13 places to the left. So in essence, I'd put a lot of those leading zeros in. Okay, so let's apply this now that we know what scientific notation is. Okay, so what we're doing here is we're going to take these numbers, which are in standard notation, and we're going to convert them into scientific notation. Okay, so I'm going to take this one in the upper left. So the first thing I need to do is I need to put the decimal between, in this case, the 3 and the 7. So I'm going to start with 3.7. Now, at this point, I need to pull out any zeros that are not significant. Well, I have 2 zeros right here. They are captive, so they are significant. So I'm going to write all of these digits down. Okay, so that is the first part of my scientific notation. Now then I go times 10, and I need to raise it to an exponent. So to figure out what that exponent is, this is how I do it. I say, okay, my decimal was here. How many places did I move it? 1, 2, 3, 4, 5, 6. Again, this is a very big number, so the exponent is positive. So if we were to take this back out, again, I would move this decimal all the way over to the right. Okay, let's do 150. All right, so I'm going to put my decimal in between my 1 and my 5. And now let's decide about this zero. Is this a significant zero? It's not a captive zero. It's not a leading zero. It's a trailing zero. But does it meet both of our requirements? No, it doesn't. It is to the right of a sig fig, but it's not to the right of the decimal. Also, there's no decimal point here, so I'm not using my quick and dirty rule. So that zero is not significant. I do not include it in scientific notation. So then I'm just going to go times 10, and now I need to figure out how many places I moved the decimal. Well, I was here, so I moved it 1, 2. There we go. Okay, so again, this is where it's really nice to take this 150 where maybe you're inclined to make that zero a sig fig if you're not really thinking about it. And once you're in scientific notation, that zero is gone. You don't need it, and it means that you're not continuing to think of that as a sig fig. Okay. Upper right hand corner, now we're dealing with little numbers. So if we're dealing with or smaller numbers, then we're going to be dealing with negative exponents. But the same rules. I'm going to put the decimal in between the 4 and the 7 here. And I'm definitely including the 3 and the 2. So the question is, do I include this 0? Notice how my leading zeros are already out. Like I don't even have to worry about them. And we know that leading zeros are not significant anyway. But is this trailing 0 significant? Well, it is to the right of the decimal, and it is to the right of a significant digit. So yes, it is significant. So I keep it in my scientific notation. And now times 10 to the 1, 2, 3, 4. Again, remember that is to the negative. Oh, sorry, I went the wrong way. Oh, not enough caffeine, right? I treated this like a big number, not a little number. Okay, so sorry, we're going the other way because this is a small number. So we go 1, 2, 3, 4. Well, I guess it had the same. That was just happenstance. So this is a small number. It should have a negative exponent. And yes, go back to where the decimal originally was, just FYI. Okay, let's deal with our monster here. We've got a lot of zeros. All right, so I'm putting my decimal here in between this 3 and this 0. So then the question is, again, all of my leading zeros are automatically out. Great, they're not significant anyway. What about all of these zeros in here? Are they significant? Yes, those are captive zeros. There are a lot of them, but they're still captive zeros, and they are all significant. Okay, so let me see how many do I have here. 1, 2, 3, 4, 6, 7, 8 zeros. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. All of my significant captive zeros. Then we have a 2. Yes, we know that's significant. Okay, so then we have a trailing 0, and we have to decide. Is it significant? Is it not significant? Okay, it is to the right of the decimal, and it is to the right of a sig fig. So yes, it is significant. So I keep it in my scientific notation right there. And now I just have to figure out my exponent for my times 10. And I went 1, 2, 3, 4, 5, 6, 7. Again, remember that negative. You've got a small number. Some people, like I'm actually counting over here to the left, but some people start at the original place and count to the right. You can do either or. It doesn't make a difference. The main thing is you know when to use a positive exponent and when to use a negative exponent. Okay, and my last one, I purposely put this in. This is supposed to be a little bit tricky. Okay, so if you have 3.75 and someone asks you to put that into scientific notation, you go, well, I already have the decimal place is in the right place. I'm not moving it anywhere. How am I going to put that into scientific notation? Well, this is how you're going to put it into scientific notation. What you need to do is you need to say that it's multiplied by 1. And to do that, we say it's times 10 to the 0, because you haven't moved the decimal any places at all. So if you need to put a number in scientific notation and it already has the decimal in the right place, you just add a times 10 to the 0, which means it's 3.75 times 1, which is 3.75. That's often a question that is put in that's purposely trying to be a tricky question, but you can take any number from standard notation and put it into scientific notation. Okay, so of course you can probably guess where we're going next. We're going to go reversed. So now we're going to take scientific notation and convert it into standard notation. All right, so all of these are in scientific notation, and let's put the decimal with all of the zeros that it needs to have. Okay, so starting in my upper left, I have a times 10 to the second. It's a positive exponent. That means it starts here, and I'm going to go 1, 2, and it's going to end up between that 5 and that 0. So this number is 745.0. Now, when you're going from scientific to standard notation, you never drop any of the zeros, because remember, once you're in scientific notation, any zeros that are in scientific notation are significant. So you wouldn't want to write this as 745. That is not correct, because you have dropped a significant digit, which is why I wanted to include that. Okay, going to the one underneath. All right, so this one is times 10 to the 12th. So I'm going to have to add a lot of zeros here. So I'm just going to go ahead and write my number as so, and I'm starting here, and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And now in all my blank spaces, I'm going to put trailing zeros. So these are all of the trailing zeros that are not significant that we pulled out from this number when it was converted into scientific notation. And you can see it makes a lot more sense to put it in scientific notation than to have all of these zeros. So let me see even where the commas would be: here, 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 and here. So if I were to rewrite this with the commas, which will help me a little bit, 902, 3 zeros, 3 zeros, 3 zeros. And that is a comma, that is not a decimal point. So this is, again, why scientific notation is just superior when you're talking about big numbers or little numbers to standard notation. Having all of these zeros at the end, like if you're putting this in your calculator, it's so easy to miss one of those zeros or to add an extra one by accident. But if you've got it in scientific notation, then you're not going to put any of those trailing zeros in, and you're much less likely to make a mistake. Okay, let's do the same thing with the little numbers over here on the right. So again, I'm just going to rewrite the number without the decimal point, because I'm going to have to put a lot of leading zeros in this one. So my decimal point started here. I'm going 14 places. Again, I'm making it small, so I'm putting in leading zeros. I'm going to go over to the left. So I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, I've got a lot of blank spaces here. Just keep adding. Okay, so those are all my leading zeros. But again, remember, when you do a decimal and you're writing a decimal down, always put a 0 to the left so it highlights where that decimal actually is. So again, you can see like this is a really tiny number times 10 to the 14th. Writing it out like this just is really hard to get your mind around. But if you write it in scientific notation, you're like, okay, this is a really tiny number. Here are my significant digits. Good, we're good to go. Okay, my last one. This is kind of the trick one that I showed you on the previous page. So we have 3.80, and remember this times 10 to the 0 equals 1. So there you go. That's standard notation. That's it. So it's good to know that trick kind of into scientific notation and back out of scientific notation. Okay, let's make sure there are no questions. No questions. Let's keep on trucking. Okay, so here we've got some scientific notation examples that need correcting. So what is the problem with these scientific notations? Well, you can see in my first one, my decimal is in the wrong place. We need to make sure that we have one non-zero digit to the left of the decimal. So I need to move the decimal place over here, which means it's 5.20. Remember, even though the scientific notation is written incorrectly, it's still scientific notation. That trailing 0 is significant. But it means that I also need to adjust this 10 to the 8th because I've moved the decimal to the right there. This is going to be 10 to the 7th. So if you're making these adjustments, and I'll show you, sometimes we actually need to make these adjustments, make sure you're also adjusting the exponent. Okay, so we have a similar problem with my second example. The decimal should be here. So this should be 7.7900. And again, we just have to adjust this -8th to account for this shifting of the decimal, and that will be a -7. Okay, and I will show you in just a few minutes how this skill is actually really, really necessary. All right, so now we're going to talk about sig figs, scientific notation. We're going to put these two together, and we're going to deal with problems with addition, subtraction. Some of these have scientific notation, some of them don't, but we're always going to be dealing with sig figs. All right, so when we're doing addition, subtraction, the number with the fewest decimal places is going to limit the answer. So when you're doing addition, subtraction, and you can mix up addition and subtraction, that's fine. You want to just count the number of decimal places. And then once you find the fewest decimal places, that's how you know how many decimal places your answer is going to have. So let's take a look at this first addition problem here. So if I just put this in my calculator, let's see, I did do that. This is the answer I get. Okay, so that is adding things correctly, but it is not to the correct number of sig figs. So because this is addition, I'm counting up decimal places. So my 2.53 has 2 decimal places, and my 0.7891 has 4. So my 2.53 is going to limit my answer. It means I just need 2 decimal places. So I need to round to this place right here, which means my answer to the correct number of sig figs is 3.32. Okay, let's go on to our second example. Again, if I just put this in my calculator, which I do have, I get -43.52028. Now, while it's really tempting to say, hey, this is how many decimal places my calculator gave me, shouldn't I include all decimal places? No, you should include the proper number of sig figs. Okay, so let's count up decimal places. I have 1, 2, 3, 4, 5 decimal places in this one. 1, 2, 3 decimal places here, and no decimal places here. Or you could say I'm actually in the ones place and not a decimal place. So which has the fewest decimal places? Well, definitely the 2, which means this answer needs to be rounded to the ones place. So your answer to the correct number of sig figs is -44, which again, I know feels really weird, but these are the rules for sig figs. Okay. Let's go on to my next. So this one has got scientific notation in it. All right, so this one's going to be a little bit more difficult. Now, you can see that I've got 10 to the third, 10 to the fourth, and 10 to the fourth. So I'm going to show you two different ways to handle this. So the first way, what I'm going to do with this one is because I have two of these numbers that are 10 to the fourth, I'm actually going to convert this scientific notation so that it is also 10 to the fourth, so that I have all of my numbers that I'm adding here to the same exponent. So basically what I'm doing is I'm going to take the correct version of scientific notation, make it incorrect so I can add things up easier. So that means my first number is going to be 0.6829 times 10 to the fourth. And of course, these stay exactly the same. So once your exponent is the same for all of your numbers, times 10 to the fourth, in terms of putting it in your calculator, you can just add these numbers right here and make it times 10 to the fourth. So this is what I mean by that. So if I add 0.6829 plus 1.6 plus 8.73050, then I am going to get 11.0134. And then I just tack on my times 10 to the fourth. Again, because the times 10 to the fourth is the same for all of these numbers, but I had to convert this one into that proper notation first. But now I've got scientific notation, but it's not proper scientific notation, right? So this is where it's handy to know how to correct your scientific notation, how to get into incorrect, and then how to get back to correct scientific notation. So what I need to do is go 1.10134 times, 10 to the fifth. Okay, so I've got my number in the correct place, but I have not done sig figs. Actually, this is going to be easiest to do sig figs in this notation right here. Okay, so let's let's see how many decimal places all of my numbers have. And again, I'm going with my 10 to the fourth as I corrected. So this has 4 decimal places. This one has 2. 1, 2, 3, 4. This one has 5. So the number that's going to limit me is my 1.60 times 10 to the fourth. It means I need 2 decimal places in my final answer. So I need to round to that one, or I could say to this one right here. So my final answer, in correct scientific notation with the correct number of significant figures, is 1.101 times 10 to the fifth. I know that feels like a lot of steps. And once you get better at doing that, you'll be able to combine some of those steps too. Like you won't have to go to this one and then round, you'll start rounding earlier. Okay, let's do another one like this, and I'm going to show you a different strategy if you don't like changing everything to the same exponent. So for this final example, I'm actually going to convert all of these into standard notation. Now, this one is a good problem for that because I've got a 10 to the second, 10 to the fourth, and 10 to the third. So they're all different. It's not like I just have to convert one. Also, because these are small numbers, but not extraordinarily small or extraordinarily big. It's not like we've got something times 10 to the negative 14th. Writing it out is not going to be too cumbersome. So again, I'm just converting all of these into standard notation. So that's going to be 0.038501. And you can see 1, 2, I moved it 2 decimal places, plus my next one, that's 10 to the fourth, 74098. And again, just double check, 1, 2, 3, 4. Okay, all right, that's fine. Plus this last one, this is a 10 to the third, So this is my standard notation. Just double check. 1, 2, 3. Yep. Okay. So we're good. So now I've taken all my scientific notation into standard notation. I can just plug this into my calculator and I get 0, 4, 7. I get a lot of digits here. All right. And now I just need to decide where I'm going to round so I have the correct number of sig figs. Okay, so let's count up decimal places. And for this one, I'm going to use my standard notation to count up decimal places just because I find it easier. So this one has 1, 2, 3, 4, 5, 6 decimal places. This has got 1, 2, 3, 4, 5, 6, 7, 8 decimal places, and 1, 2, 3, 4, 5, also 6 decimal places. Okay, so my final answer needs to have 6 decimal places. So 1, 2, 3, 4, 5, 6. I need to round to that 3 right there. So then my final answer with the correct number of sig figs, 4, 7, 3, 9, 4. Okay, and you could turn this into scientific notation if you wanted to. That would be 3, 9, 4 times 10 to the negative second. Again, it would depend on the question and what your professor would like you to do. Okay, so you've used all your skills with scientific notation and sig figs and put them together, but this is just addition subtraction. We still need to take care of multiplication division. All right, so we have a different set of rules for multiplication division. So in addition subtraction, again, we worked with counting up decimal places. With multiplication division, we're counting up just total sig figs. So we're going to find the number with the fewest significant figures, so whichever one has the smallest number of sig figs, and that is going to limit our answer. So again, we're ignoring where the decimal is and we're just counting up sig figs, and whichever one has the fewest, that's how many sig figs our answer should have. Okay, so let's start with our first example here on the left-hand side. So if I just plug this calculation into my calculator, I get this answer right here. So now I have to decide how many sig figs my answer needs to have. Okay, so this 0.02, how many sig figs? 1, which I know feels like, what, just 1 sig? But yes, just 1 sig fig. Remember, these are leading zeros. They are not significant. And 125.1 has 4 sig figs, but my 1 is going to limit me. That means my answer should have 1 sig fig. So my answer is simply 3. Okay. Those are questions that you'll find when they really want to test. Do you know your rules for sig figs, or are you just going with what your calculator gave you, or are you just going with what feels right? Always make sure you're following your rules. Okay, let's go on to this problem down here. So if I plug this one into my calculator, I'm going to put it underneath. I get just a crazy number here. 0.2703. Okay, how many sig figs do I need? Let's count up sig figs. All right, so my numerator has 4 sig figs. Remember that 0 is to the right of the decimal and to the right of sig fig, so it is significant. These are all leading zeros. They're not significant. It's just this 3 and the 7, so there are only 2 sig figs in the denominator, which means I need 2 sig figs in my answer. Okay, I could write this with and make all of these trailing zeros, and then they would not be significant, but this is a case where it's going to be better to use scientific notation. So I'm going to convert this to scientific notation times 10 to the 1, 2, 3, 4, 5, 6, 7. And you can see there are my 2 sig figs. So again, it's just really handy to use scientific notation for these really kind of crazy big or crazy small numbers. Okay, next, here we go. So if I just plug this into my calculator, I get a lot of decimal places. Okay, this just kind of goes on forever, and this is times 10 to the negative 7th. So how many sig figs do I actually need? Well, let's figure it out. Okay, so 1 point, that has 4 sig figs, 4.5, that has 2 sig figs. And just as a side note, these exponents here, they are not part of your sig figs at all. It is only this first number here that determines your number of sig figs. Okay, so my 4.5 is going to limit me. It only has 2 sig figs, which means I'm rounding right there. So my final answer is 3.8 times 10 to the negative 7th. Okay, I've got my monstrosity down here. Now it's still all just multiplication and division, but we're going to take this at least a little bit stepwise. So I'm going to take my first calculation here. This is 2.06 times 10 to the negative 3rd. Again, at this point, I'm not really worrying about my sig figs because I'm going to have to decide that at the very end. I'm just trying to simplify. So let's do what's in the parentheses there. That is 578. I'm going to leave that denominator alone for now. 2, 3. I'm going to keep on simplifying. 2.06. This is just here. And then this is 8.26 times 10 to the 3rd. And so now, before I do my final answer, what I want to know is how many sig figs I need. Well, I can go back and just look at my original problem and determine my sig figs. All right, so I have 4 sig figs here. I have 3 sig figs there. I've got 3 here. I've got 1, 2, 3, 4, 5 there, and 1, 2, 3, 4 right there. So my answer should just have 3 sig figs. So when I put this into my calculator and I round, I'm going to get 17.0. Okay, so that was kind of our large one there. Now, before we do our mixed operations, I do want to talk about potential calculator problems. Okay, so this is why I put it in red. Calculator errors ahead. All right, so let's just think about this really, really simple problem. What is 1 times 10 to the 4th? That's just 10,000, right? So it would go 1, 2, 3, 4. And 10 to the 3rd is just 1,000. I mean, this is one that you can do in your head, right? So 10,000 divided by 1,000 is just 10. Okay, but let me show you how your calculator can trip you up. So what I've got here is I've just got to make sure you can hit. This is just a TI. I know many of you have these TIs. So I'm going to put this in my calculator. 10 to the 4th, 0.0 times 10 to the 3rd. Okay, so I'm going to try and show this as much as I can. So you see how I put that in? Times 10 up caret 3 times 10 up caret 4. All right, if I hit enter here, this is the answer I get. And you're like, no, right? You'd be right, because you know the answer should be 10. So what went wrong? Well, when you put it in your calculator like that, your calculator does not see this as the number 10,000. It sees this as a math problem. 1 times 10 raised to the 4th. And then you're divided by 1 times 10 raised to the 3rd. So we need a way to talk to our calculator and say, no. I'm using scientific notation. This 1 times 10 to the 4th, that is a single number. It is 10,000. I don't want you to do this multiplication. So to do that, what you want to do is you want to look at your calculator and you want to find your capital E or your capital double E. And for this calculator, it's right above the comma right here. Okay, so I think I just typed it in. No, I typed in a comma. Sorry, it's right there. So the proper way to put this into your calculator so you don't get that crazy error, which is I think that's 10 to the 7th, is like this. You're going to use that E. Okay, and so your calculator is going to look like this. Can you see how it's got an E in there now? And that is the way we speak to our calculator to say, hey, this is scientific notation. This is one number. Do not treat it like a math problem. And you can see when I hit enter, I get the correct answer. So when you're putting scientific notation into your calculator, make sure you're using that capital E, because otherwise you're going to run into problems like this, where even though like what you have written down and your methodology is good and you're getting the right numbers, your calculator will give you the wrong number. And that is just so frustrating. So whatever calculator you have, whether you've got a TI, and again, if you have got a TI, look for that small e above the comma. Whatever calculator you have, make sure you know how to put in scientific notation properly. Okay, that was just a word of caution. And now let's go to our mixed operations. All right, so when you have mixed operations, you need to make sure that you're keeping track of your sig figs, depending on if you're doing an addition, subtraction, or multiplication, division. And what you're going to do is you're just going to follow regular order of operations. But I'll show you how I do this, because we don't want to start rounding really early, because if we have a very long calculation and we're rounding on each step, we're going to end up with rounding error in our answer. Now, this is why it's nice to have one of the TIs, because you can just keep that answer in and just continue on with the calculation. And it makes it easy to see. At least for me, it makes it easy to see. Okay, so I am going to first simplify this first term. So when I put this into my calculator, I get 6.4638. And then I'm just going to carry this 7.33 down. Okay, so that's what my calculator gives me, but where am I going to round this? Well, I'm doing division here. So I'm going to use my multiplication division rules. I'm just counting up sig figs. So I've got 2 sig figs in the numerator, 3 sig figs in the denominator. So I should be rounding to the tenths place right there. So I'm going to keep that full number for my calculation, but I'm just making a note to myself, hey, you are rounding to this place because you just need 2 sig figs. Then I can do my addition, and if I put that into my calculator, I get 13, and then I'm going to have 8, because I'm doing addition, subtraction, and I'm looking at decimal places. All right, so this number right here, even though I've written out extra digits, it only has 1 decimal place. 7.33 has 2 decimal places, so my answer should only have 1 decimal place, hence why I have rounded it right there. So again, I like to not go ahead and round this to 6.5, but keep those extra digits while I do the calculation, but remembering that that is my place so that I know where to round when I'm ready to round my final answer. Again, when you get long calculations, if you round each step, you're going to get an answer that is wrong depending on how many steps you have. And again, that's frustrating when you've done everything right. It's just a rounding error problem. Okay, let's go on to my second problem right here. Again, I'm going to follow order of operations. I'm going to do what's in the parentheses first. And if I write down, this is what my calculator gave me, but how many sig figs, right? Because you can never trust your calculator to give you the correct number of sig figs. It won't. Okay, because I'm doing subtraction, I'm looking at decimal places. So I have 2 decimal places here, 1 decimal place here. So I'm going to round to 1 decimal place. Again, I'm not going to drop that 9. I'm not going to round it yet, but I'm just giving myself a note. Hey, you need to round at that place. And then I'm going to divide by my 5.3. And so for my sig figs, for my final answer, this calculation has 1, 2, 3. It has 4 sig figs, and this one has 2. So when I put this in my calculator, I want to make sure I round to 2 sig figs, and that is going to give me 63. And that's it. So I know it feels weird when you've got all of these decimals over here, like, shouldn't I have a decimal place? Well, no, just make sure you're following your rules each step. Again, do the parentheses first, follow those addition subtraction rules, and then do multiplication division. Okay, but let's practice a couple more because these mixed operations can be difficult. Okay, so we've got a much larger calculation, and look, we've got some scientific notation here too, right? Okay, so I'm going to start with what is in parentheses. So if I do this calculation, let's see, what does my calculator give me? An 8.1. Okay, so where do I need to round though? Okay, so this is addition, subtraction. I'm looking at decimal places. So I have no decimal places, I have no decimal places, and I have one decimal place. So I'm making sure that I'm going to round there at that 8. But again, for now, I'm going to keep that 0.1 there because I don't want to introduce that rounding error. All right, so now I'm doing multiplication division. Sorry, that times was kind of small. So now I switch rules to multiplication division. I'm looking at total number of sig figs. So I have 1, 2, 3, 4 sig figs in this answer, or sorry, in that number, and just 2 in this one. So my answer should have 2 sig figs. So when I put this into my calculator, which I did do, here's my answer, 7.7 times 10 to the 10th. Okay, let's do one more. We'll do a really big one here. Okay, so we've got a couple of things going on, but I'm going to start with what is in my parentheses. So again, if I put this numerator in my calculator, what does it give me? 46.046. Again, let's figure out where we need to round. So I have 3 decimal places, 2 decimal places, and 3 decimal places. So I just need 2 decimal places. So there's my little reminder. Okay, and I'm just going to carry this denominator forward and this scientific notation, which you may recognize as Avogadro's number. So I just made it a little more chemistry. Okay, so if I'm going to take and simplify this guy here, then this is what my calculator gives me, 0, 1, 3. Again, I'm just going to carry this Avogadro's number, but let's see, where am I going to round that 11? This numerator has 1, 2, 3, 4 sig figs. The denominator has 1, 2, 3, 4, 5, 6 sig figs. So I need 4 sig figs. So 1, 2, 3. So I need to round at that 2. But again, I'm going to carry everything forward as I do my final calculation. And in my final calculation, because I'm doing multiplication division, let's see, this has 4 sig figs, and this has 1, 2, this also has 4 sig figs, so my answer should have 4 sig figs. So putting this into my calculator, I get 6.877 times 10 to the 24. And you can see I went ahead and rounded this to 4 sig figs. Okay, so that is how to do mixed operations. Again, it can be tough, but just break it down step by step and give yourself all of those little notes that you need. As always, we are here for you. So whatever questions you have, please let us know. If you want another topic for a live stream, if you want extra practice with more mixed operations and doing significant figures and throwing scientific notation in there, we can absolutely do that. Again, as you're moving through your chemistry classes, just let us know what topics you're going to find most helpful for the live streams, and we will make sure that we get those topics to you. And thanks so much for joining us. Enjoy the rest of your Wednesday. Bye.